our condition is going to be if there are points. So this is going to be my condition. And if you see now, we have our forces calculated only in the points, in the voxels within the search radius. Okay. And here we have our forces. So we can add a multiply node after each force. To just have a scale parameter or a multiplier parameter that, and this is a thing that we already did before. So this is going to be our follow force scale, follow force scale, and the default is going to be 1. Okay, we can also add a multiply here, multiply our twisting force here, or the orbit force. We can call it orbit force, orbit force scale, orbit force scale, and the default is 1. Then we can another multiply for our suction force. So this is going to be my suction force scale, my suction force scale. Okay. Now if we go outside here and set these forces to 2.5, 2.5, 2.5. Okay. I think there is a problem here. Oh, guys, I'm sorry. Here in the point cloud, I here want to filter the normals. I forgot to do this. And in this bound node, I think our volume is slightly smaller than we want, so I can increase the padding to make it bigger. Okay. If we now visualize it, oh yeah, this is great now. We can visualize every force alone. So if we just visualize our orbit force by making the other forces 0, as you can see now, we have the vectors around our curve. If we visualize our suction force alone, as you can see, vectors looking towards our curve. If we visualize our follow force, you'll have force following your curve like this, and we can add them together like this. So now we can add a null here, call it out velocity, and if we go now outside and visualize our SOP guide, it will not show what's inside here in the volume trail unless we show the guide geometry and play one frame. I think it's not being visualized because it will always visualize the output node if we delete it. Okay, maybe we can connect it to a velocity update, I think, maybe. Let me hide other objects. Why isn't it showing on the viewport? Yeah, here we go. Now it's showing when we press this show guide geometry. My viewport is lagging or something, so it's very buggy. I can visualize it like this. Okay, so this guide geometry is great now. Now inside here, we want to add some controls to our force for the user. Now what we can do, this subtract node here, we have now a vector from the voxel to our curve. What if we want to use this vector, okay, and add it as a control to be able to control our force when it is very near to the curve or far from the curve within the search radius. So for example, we can take the length of these vectors that come from the voxels to the curve and add a fit range, and we can fit them between 0 and 1. Then we can add a ramp, and this will control the force from just in the area of the radius around the curve. So for example, you can make your force less when they are far from the curve. You can make them higher when they are very near to the curve. Okay, so to do this, we can add a length node, and I think you are familiar with this now because we did it in the Millstorm or the vortex force. And we can add a fit range. We want to fit this between 0 and 1 in the destination, but in source min and max, the source max, we just want to use our maximum radius. So when the force are in the maximum, in the area of the maximum radius in this area or more, they are going to have a value of 1. When they are very near to the curve or when the distance is 0, they are going to have a value of 0. And between in these areas, you'll have ascending values from 0 here to 1 here at the periphery in the maximum radius area. And now we can add a ramp for each of these forces. We have already a multiply node here, so we can add a ramp parameter for each of these forces. So for example, we can call this suction force from curve ramp, and I like to use the informative names even if they are too long, because this will help you a lot during creating OTLs, because when you create a lot of parameters you may get lost. And for now I want my RAM to be like this, and we can multiply it here of course, from the outside our ramp. I don't know why I just edit the default here. It doesn't edit it from outside. But anyway, we can also add another ramp for my twisting or orbit force. Houdini hangs a lot when I'm just recording. Suction force ramp or from curve ramp. I'm sorry, not suction, orbit. And orbit force from curve ramp. Okay, and it's a spline. Make it like this. Okay. And another ramp. I know that these operations or these steps are a little bit boring, but they are very important. Follow force from curve ramp. Then add it here. So now you have a ramp for each force where you can just make your force or control your force. So for example, you here have a distance of 0 and here you have a distance of the maximum radius. You can control your force. Maybe here, if you can see now, we are making our suction force 0 when it's very near to my curve. We can do something like this, for example. If you see now, they are 0 and they are stronger here in this area. Okay, so this is the idea. And we can also control our global force or the force after the addition of the 3 forces. So you can control your force as a whole by this multiply node. You can create a parameter, call it global scale. So now you can increase or scale your force as a whole from outside. Maybe you can add another ramp parameter based on the distance for the whole force. Okay, so now this is going to control the whole 3 forces together, and you can call it global force from curve ramp. Global force from curve ramp. And we can add it here. Okay, here we go. We can also control each of these forces by the length scale. If we just create another point cloud filter to filter my length scale from this point cloud here, float length scale. So now we here are filtering my length scale. We can add a ramp now for each of these forces depending on the length scale, but I will leave this for you guys. I will just add my ramp here to control just the general force or the global force, but you can surely control your suction or follow or orbit force by three different ramps like we did by from the distance like we did in the distance here, like we did in like we did with the distance here. Okay, so here we can call this along or global force along length ramp, global force along length ramp. Okay, and it's a spline ramp on the outside. Let me make it like this because I don't want now my force to be changed by this ramp. And I connect it here. I connect it here. Okay. Uh, okay. Here we go. We can here, if you can see, can make our force 0. For example, till the end of my curve. Okay, we can control along the length now. Oh, I'm sorry, I'm playing with the wrong ramp here. Sorry. Here. Where is it? Can see if you can see now. We can cut our force along the length of if we want. Okay, so this is a great control. I think now we have great controls. We can just now use this velocity field. You can guys just manipulate it as you want, but we can use this velocity field now in our simulation, and I'm going to show you how to do this. Now let's add this velocity field to the velocity of the simulation, because here it's just calculated in this sub network. We need to grab it from there, and as we said before, the sub guide is not going to be computed unless you show the guide geometry or you call the fields from it or the things from it. In this case, it's the velocity field. We are going to call it through a gas field VOP. Okay, so here we have our velocity. Here we need to call it there. And we will also want to, add a null here for the curve, because we will need this reference, or we'll need the curve points. Okay, so here inside this gas field VOP, we here have two velocity fields that we want to grab, and we will mix between them in a great way. We're not going to add just this velocity field to the velocity of the simulation. I mean the velocity field here from the subguide. We will not add it directly to the velocity field of the simulation, but instead we are going to mix between them. So to access the velocity field, so we want to access the two velocity fields the first one, if we create a bind node, okay, we can access the velocity field of the simulation. And if you play your simulation, if you play your simulation, if you play your simulation, this is the velocity of the simulation now. The smoke that is rising up like this, okay? And and if we want to grab the velocity field from the subguide, we can use a volume sample vector. I don't know if I used this before or not, but the volume sample, as we said, I think before, it samples the value of the voxels of a volume depending on this volume sample vector here samples the values of the voxels of a field or a volume, okay, and you connect it to a position, okay, and it sees the points or the voxels, or here in this case, so this volume sample vector here is going to sample our velocity values, okay. We just give it the position of our voxels of the simulation, and it sees, okay, the position of these voxels, it sees the position of these voxels in our simulation, and it says, hey, I'm going to sample the values of the velocity field that is created in the subguide in the voxels that near to the voxels of the simulation itself. So for example, to make this clear, here we have our density field, okay, and we have it's just a field composed of voxels. So for example, in this voxel, it has a position, okay, and this volume sample takes this position of this voxel, for example, and searches for the near voxels of, or the most near voxel of the velocity field of this subguide, and samples or takes the value of this voxel. So for example, it will sample the nearest voxel of this field here, which is this voxel, okay. So this voxel will sample the value here from the voxel that is that is nearest to it, okay. So to do this now, or to make this volume sample vector access our velocity field that is in the subguide, we can't connect it here to the inputs. So to access our velocity field from the subguide here, we can, here in the inputs, we can either here select the input, first input or second input. We are going here to select the first input, or we can connect it to the first input here, okay. And here come in this gas field VOP and inputs, here you have this input who can add a SOP path, and you can go to the SOP guide and sample your velocity field, which is really great. So now you are sampling your velocity field, and the velocity field of the simulation, you have the two velocity fields. What we want now is that we want to subtract these two fields. So now you have the difference between the two fields. We want, if the difference between these two forces is larger than or equal to 4, for example, we want this velocity field from the subguide to affect our simulation stronger, or to be the dominant in our simulation. But if the difference is less than, or if it's between 0 and 4, we want the velocity field of the simulation to be the dominant. And what will this do is that, for example, if the difference is 0, if the volume sample is mostly the same as the velocity of the simulation in a specific voxel, we don't want to add more of it. We just want to add some of the natural velocity that comes in the simulation due to the buoyancy and the smoke surely has temperature and it's floating. Okay, because we want our simulation to be natural. We don't want the smoke to stick very much to our curve. Okay, so now we have this difference. If we create a fit range here, I'm sorry. Firstly, we want to take the length here of the subtracted vector, and if we use fit range now, we here have the source min and max. If we set this to 4, now if the values, or if the difference between the velocity of our sub guide is, and if the difference between the velocity of the sub guide and our simulation velocity is 0, we are going to have a destination minimum of 0. And if the difference is 4 or more, we are going to have a destination of 1. And if the values, or if the difference is between 0 and 4, we will have ascending values from 0 to 1. Now, after we add this mix node, we can connect this fit range to the bias here. So this bias is from 0 to 1. I think we used the mix node before. If it's 0, it's going to use this input. If it's 1, it's going to use this input. Okay, so we want when the length here, or when the difference here is big, or is bigger than 4, okay, we want to stick with the velocity of this velocity field from the sub guide. But if the difference is too little, or if it's 0, for example, we want to use the velocity of the simulation to add more natural effects. So now the simulation will go, and the difference in the first frames will be high because the smoke is going to float due to the buoyancy, so the difference is going to be larger than 4. So it's going here to use, or the velocity from the sub guide is going to be dominant, so the smoke will start now adhering to the curve and will follow the curve. Okay, and if the difference after the smoke adheres too much to our volume sample from the sub guide, then the velocity field from the simulation is going to be the dominant, because this will make our smoke, float more naturally by the temperature and the buoyancy. And this is going to be a balance here, and surely you can promote this source max parameter, and this can be controlled by the user. Okay, and what we can do now, we can bind export this as the velocity of our simulation. Okay, I hope this idea is clear to you now. If we now play our simulation, you'll find something like this.